My name is Jake Moody and I'm an application engineer at PTC. In this demo video, I will take you through the fault tree analysis module of the Windchill Quality Solutions tool. The fault tree module offers a self-aligning diagram modeling tool that allows you to quickly and easily model a top-level failure and the hardware, software, and/or human errors that led to this failure. There are a number of different gate and event types that are used within this methodology to build up the logic-based diagram used to calculate your reliability and safety parameters for your complex systems. There are many features built into the fault tree analysis tool that allow you to meet the goals your organization has set for a fault tree analysis. These include library functionality to reuse data and define object styles, lambda tau calculations for well-maintained systems, cut set highlighting, several common cause failure methodologies, and an integrated event tree evaluator. A major benefit of the integrated solution that Windchill Quality Solutions provides is the ability to easily share information between modules. With Fault Tree, we can pull failure data from a number of different sources, including reliability prediction, a specific mode in an FMEA analysis, or a Markov model. We can also incorporate repair data for the events in our tree from the maintainability prediction module. In this demonstration video, we'll cover the various tables and forms associated with the fault tree module. We will highlight the library functionality to utilize previous fault tree analysis that has been completed. We'll also show you how to construct a simple fault tree diagram, link it to another diagram using our transfer gate, and calculate our results to display in both reports and graphs. The fault tree interface is broken up into two views. In the upper portion of the interface, you have your fault tree table, which is going to provide you with an indentured view of all the fault trees for the currently open system file that you're working on. In the lower portion of the interface, we have the fault tree diagram, which is going to provide you with a visual representation of the fault tree diagram that you're working on. We're going to go ahead and create a new fault tree at this time utilizing a fault tree analysis that we've done in the past. I'm going to click on the Browse Libraries option, and we can see a listing of all the fault tree diagrams available in our fault tree diagram library. To reuse this information, we can simply click and drag into our fault tree table, and Relics will populate the table with the data that was used when we performed this analysis last. I'm going to go ahead and close the library browse window, and we can see all of the data as well as the structure has been pulled in for us. We can modify this fault tree diagram by adding additional gates and events very easily utilizing the fault tree tools toolbar. I'm going to go ahead and insert an OR gate as an input to my overheated battery. So once I click my mouse, you can see that it's going to automatically align our fault tree diagram. When I right click, I'm going to leave insert mode, and we can modify some of the properties associated with this gate. We can do our data entry either in the table above, or we can double click the item in the fault tree diagram to access the properties for the item. On the general page, we have general descriptive information. I'm going to go ahead and call this our battery is defective. On the calculation data tab for a gate, you can specify the logical condition. On the inputs page, we can identify all the inputs to this gate, and at the bottom of this page we can also add inputs from here as well. The graphic page is going to allow us to associate an image file from our machine with that particular gate or event. The user properties page allows us to store information that's not used for any specific reason within Relics. We allow you to gather your own information and configure these labels to meet whatever your internal process is. The remarks provides us with a memo field where we can store up to 64,000 characters. And the cut sets, the reliability importance measures, as well as the fault tree results sections will all be updated once we've run the calculations for this fault tree diagram. Once I click OK, my changes are going to be applied to that gate, and we can continue on with our data entry. I'm going to go ahead and insert two basic events as inputs to this defective battery by selecting them from my fault tree tools toolbar, and I'm going to simply click twice to insert two basic events. For the first event, I'm going to access my properties to highlight the differences between our gates and our events. With our event properties open, we're going to notice a lot of similarities between our event and our gate properties. The general page is exactly the same. We can specify general descriptive information. Here, I'm going to enter in anode cathode short as my description. On the Calculation Data tab, in addition to being able to specify our logical condition, we can also define how we're going to input our failure information for this event. We have a couple of different options. We can do user-defined parameter definition, common cause failure groups, as well as linking it to our prediction, FMEA, or Markov data. With user-defined selected, down below I'm going to specify a constant probability value of 0.005, and that will be used as the failure information for this event. On the library event page, there are event libraries that can be utilized to pull data from. Again, we have a graphic where we can associate an image from our machine with this particular event. We have our user properties that we can configure for whatever our internal requirements may be. And we also have a remarks field where we can store that extended description of this particular event. Again, once I click OK, we're going to see my changes have been updated in the diagram itself. Another option that we have is the ability to link data. It's really a strong point of the Windchill Quality Solutions tool, and if we right-click on an event, there's a data linking option, which is going to allow us to link to FMEA, Markov, or prediction. We're going to link to prediction for this example, and in my system tree item drop-down list, I'm going to link this to the battery itself. Once I click OK, that link is established. You can notice the blue link icon in the upper right-hand corner. The only way we can make changes to this failure information now is to go back to our prediction and rerun our calculations. Within the Relics Fault Tree tool, we also have the ability to utilize transfer gates to simplify our fault tree diagram by breaking it out over multiple diagrams. To demonstrate that here, I'm going to right-click on my defective battery, and in the right-click menu, we're going to see the break into transfer option. Once I select that, it's going to break that defective battery off into its own top gate, and you can notice the transfer icon off to the right of that OR gate. If we right-click, you have a transfer option in the right-click menu. We can transfer back to the original diagram, and we can see that our defective battery is now represented with the triangular transfer option. So we can simplify our diagrams by breaking them out over multiple levels. We can also duplicate the logic of a branch. So if we wanted to reuse that defective battery elsewhere in our fault tree analysis, we could very easily reference that transfer gate and use that logic again. So we've covered the basics of entering data into our fault tree analysis tool. The next step is to go ahead and run our calculations. I'm going to click on the calculator icon and make sure that only fault tree is selected. There are some other options for fault tree. On the general page, we have our time interval for our time-dependent calculation. We can choose to perform exact calculations. If we don't choose to run exact, there are some other calculation methods that are available. We're going to start calculating at our topmost gate. We're going to calculate for all the gates in our fault tree. And we can also choose which calculations we want to run. On the advanced page, here are the other calculation methods that are available if we hadn't selected exact on the previous page. And we also have precision for our Markov model. So for all the dynamic gates that are supported within the Windchill Quality Solutions tool, we utilize a Markov model to calculate the results, and you can choose the precision for that Markov model. I'm going to go ahead and leave those defaults as they are. Click OK, and Relics is going to generate the calculated results for me. We're going to be provided with the results in a dialog box. If we close out of that dialog box, we can also see those results populated in the diagram itself. If we double click to access the properties for a gate, we can see that our cut sets, our reliability importance measures, as well as our fault tree result windows have also been updated with the latest calculated results. From a qualitative standpoint, if you chose to run your cut sets, we can highlight those cut sets visually simply by right-clicking on a gate and selecting the Highlight Cut Set option. This is going to visually highlight the cut set so we can quickly identify if we have single-point failures. Over on the left-hand side, it's also going to sort them by probability of occurrence if you entered quantitative data. We can cycle through those cut sets, And when you're done reviewing them, we can close that window to be brought back to our default view. Once you've run your calculations and taken a look at your results, you may want to generate outputs based on those results. We offer both reports and graphs to accomplish this. If I click on the report preview button, we can see a listing of supplied reports that are available within the Windchill Quality Solutions tool. We also offer a report wizard, which will allow you to configure your own reports based on your specific requirements. For this example, I'm going to run the fault tree summary report, and I'm going to run that for our gate 15. I can click OK, and Relics is going to generate that report for me. The first section of the report is going to be the results at each of the gates and events within our fault tree. The next section of the report is going to provide us with a description of each of those gates and events. And the final section of this report is going to be the diagram itself. You'll note wherever a transfer gate is used, there's clear navigation where that transfer is coming from, as well as where it's going to. Standard output applies for these reports, so we can print them out directly to a printer. We can also save them off in a soft copy in a Microsoft Word format, PDF, pretty much any format you require. Windchill Quality Solutions can generate that for you. I'm going to go ahead and close this report. We also have graphing options that are available as well. If I click on the graph icon at the top of the interface, again, there are a number of graph templates that come supplied with the software, but if you need to create your own configured graph, we also do offer a graph wizard, which will walk you through that process in a step-by-step fashion. I'm going to go ahead and run the unreliability over time, click OK, and Relics will generate that graph for me. So here we can see our unreliability over the time interval we specified when we ran our calculations. So here in the fault tree module, we quickly took a look at how to create a fault tree based on a library, how to create a fault tree utilizing the fault tree tools toolbar. We calculated our results and then generated useful reports and graphs. I hope this gives you a good idea of the capabilities of the Windchill Quality Solutions tool fault tree module, and if you have any questions, please don't hesitate to let us know. Thank you.